Obviously, such an electrode must be capable of sending electrons into the outer circuit, as we shall see after some time. The second concept is osmotic pressure of the solution. We have just learned the concept of solution pressure of the metal, which is related to the tendency of metal to go into the salt solution as its cations. Now think of the reverse process. That is, what will happen if the metal ions Mn plus from the solution have dominating tendency to get deposited on the metal rod? This tendency is called osmotic pressure of the solution. Presently, it has nothing to do with the colligative property osmotic pressure which we had studied in the chapter of solution. Well, again, you cannot imagine that by chance all the metal ions of the solution will be deposited on the metal rod, leaving behind only anions in the solution. No, this also can never happen, because once some M plus N ions get deposited on the metal rod, they start repelling the further M plus N ions to come closer to the metal rod, so that now metal rod becomes positively charged and a layer of anions is formed in the solution surrounding the metal rod. We see that in this situation, the electrical double layer formed becomes just opposite to that formed when solution pressure of the metal was dominating. Therefore, as shown in the following figure, we get an electrode system which, if connected to some source of electrons, for example our previous electrode, will receive the electrons so that following reduction may occur on its surface. That is, Mn plus N electron giving M solid, its reduction. Such a situation will arise when a copper rod is placed in copper sulfate or copper nitrate aqueous solution in comparison to zinc rod in zinc sulfate solution. Thus we see that with the help of these two concepts, we have been able to develop the two electrode systems which are the most important components of a galvanic cell. Here, before we proceed for the construction of cell and characterization of these electrodes, I would like to give you a word of caution in the form of following note. The first thing is, the terms solution pressure of the metal and osmotic pressure of the solution, as discussed above, must be considered as concepts to understand the polarity of electrodes, and moreover, do not think that if zinc is forming a negatively charged electrode with respect to copper, it shall always be doing so with respect to all other electrode systems. I mean to say that out of the two electrodes we take for making a cell which will be behaving as negatively charged and which as positively charged, it is all relative. A better method for deciding this we shall learn later on under the heading of electrochemical series. Second point, it is just possible for a metal that both the above tendencies may balance each other. In such a situation, the electrode will be treated as null electrode because it will be chargeless. Such electrodes themselves cannot make a cell, but they can help in construction of other electrode systems.